Welcome back, everybody. Okay, so in this section we are going to be doing equation solving. Okay, it's a little different from the last couple sections where we just add, subtract, multiply, and divide. Yeah, we're going to actually solve for x. Okay. So here's the first problem. One over x plus 1 equals 2 over x. I hate fractions. Hopefully that triggered something in your head. We've kind of done this before in chapter 3. If we can somehow eliminate the fractions, then we just have whole numbers to work with, which is so much easier. Here, let me give you a problem that you folks may be familiar with. Okay, something that's a little easier. So we have 3 over 5 plus 2 over 3 equals x over 9. Okay, same idea. If we can get the denominators to match, then we can eliminate the denominators, and then we can just solve for x. So, if you look, we have 5, 3, and 9. We need to get the same denominator. We can change them all to 45. So, if I multiply this one by top and bottom by 9. If I take this fraction, multiply top and bottom by 15, and this one by 5. Yeah? Then we'll have 27 over 45 plus 30 over 45 equals 5x over 45. Notice all the denominators match. Yeah? So if we multiply all the numerators by 45, that'll cancel every single denominator. Yeah, there's a sort of balance here. Yeah, that'll leave us with 27 plus 30 equals 5x. Notice, yeah, if I multiply top and bottom by 9 or 15 or 5, that keeps the fractions the same. It just changes the denominator. Yeah, so there's a sort of balance here. Yeah, same with this equation. If I multiply the left side and the right side by 45, the two are still in balance. Yeah, by doing so, it eliminates our denominator. And then we just have whole numbers to work with. So, we take this now, and we can solve for x. If we add, that comes out to 57 equals 5x. And then we just solve for x. We get x by itself. Divide both sides by 5. Our answer here is 57/5. We're going to do the same thing with this problem. We need to get the denominators to match. Now if you look at the problem, there's something that denominator has that this one is missing. We need to multiply by x, top and bottom. On this side, it's missing something that the other denominator has. We're going to multiply top and bottom by x plus 1. Now the denominators match. X over x parentheses x plus 1 equals 2. I'm going to distribute the 2. 2x plus 2 over x parentheses x plus 1. Yeah? It's just like this. Yeah? If we just keep it in balance, we get the denominators to match, top and bottom. Now all we got to do is left and right. We multiply x parentheses x plus 1 to both numerators. It'll cancel out the denominator. That'll leave us with x equals 2x plus 2. No fractions. Now we can just solve for x. We need to get rid of x off of one side. So subtract 2x. That'll leave us with negative 1x equals 2. And then we just get x by itself. Our answer is negative 2. So it's a little different, but still kind of the same. Yeah, if we just get the denominators to match, yeah, we balance top and bottom or left and right. We can eliminate the denominators and we can get x by itself. Let's try this again. Okay, x plus 2 over x equals 3. These do have denominators. Just one. Now, we need to get the denominators to match. Common denominator is x. So, we're going to multiply top and bottom here by x. This denominator is already x, so we don't need to do anything to that one. Yeah. So, this one we should multiply by x as well. Now we'll have x to the second over x plus 2 over x equals 3x over x. Yeah, all the denominators match, so we need to eliminate the denominators. Multiply both sides, all the numerators on both sides, by x. That'll eliminate the denominator. Yeah, so we can cancel. Now we just have whole numbers. In a sense, not whole numbers, but no fraction. X squared plus 2 equals 3x. Since there's an x squared in the problem, we should try and get a 0 on one side. We're going to get it in standard form. So we need a 0 on one side. We need to get rid of 3x. So subtract 3x on both sides. That'll get it into standard form. So now we have a 0 on this side. X squared minus 3x plus 2. Remember how to solve this? Yes, we need to factor. They have nothing in common. We'll go to two sets of parentheses. We need x squared. X and x. We need a positive 2 at the end. It's a negative 3x in the middle, so it's got to be minus 2 and a minus 1. Now that we have it factored, each of the factors have to equal to 0. So x minus 2 equals 0 and x minus 1 equals 0. And then we solve for x. So x equals 2 and x equals 1. So, unlike the previous problems, we actually have two solutions. Oh yeah, I forgot. We are solving for x, so we need to write the answer in set notation. So, there are two solutions this time, 2 and 1. So, all the other equations we've done before, we've always had one solution, but now we actually have 2. Yeah, because there was an x squared in the problem. So, even these, we should have been writing them in set notation. This one is a negative 2. This one is 57/5. Yeah? So just gotta remember, when you solve for x, we need to write the answer in set notation. Try another one. Okay, wait, let me switch the paper. Okay, next problem. 4 over x plus 2 equals x squared over x plus 2. Okay, the denominators already match. So, we don't need to get them to match, we just need to eliminate them. So, left and right, we are going to multiply both sides by x plus 2. That'll eliminate the denominator. Okay, we're left with 4 equals x squared, no fractions. Since there's an x squared in the problem, we should try and get this in standard form. We need to get a 0 on one side. I'm going to get rid of the 4. So, to get rid of the 4, I'm going to subtract 4 on both sides. Now we have a 0, x squared minus 4. Okay, since we still have an x squared in the problem, we should factor. Two sets of parentheses. We need x squared at the front, x and x. We need a negative 4 at the end. Since it's negative, the signs have to be different. Plus and minus. We still need the 4. 2 and 2. Now that we have it factored, each of the factors has to equal to 0. And then we solve for x. So x equals negative 2 and x equals 2. You okay with this? Actually, there's something wrong with it. Here's the thing. We're so used to solving equations that we haven't been checking. But really, each of the solutions has to work in the original problem in order for it to be a solution. Yeah? So here's what we're going to do. We're going to take the numbers and plug it back into the original problem. So let's start with the negative 2. I'm going to take the negative 2 and replace it for x in the original problem. So 4 over negative 2 plus 2 equals negative 2 squared over negative 2 plus 2. So all I did was replace the x with negative 2. Now we simplify. 4 over 0 equals negative 2 squared is also 4 over 0. It seems to work. There's only one problem. You cannot have 0 in the denominator. So we found an answer, but really negative 2 is not a solution. We need to cross that off. Let's try the 2. We're going to take the 2, replace it in the original problem. So 4 over 2 plus 2 equals 2 squared over 2 plus 2. Let's simplify. This would be 4 over 4. 2 squared would be 4 over 4. 1 is equal to 1. This is a true statement, so we know it works. So 2 is a solution. So although we found 2 answers, really only one of them worked. In set notation, our answer is 2. This, by the way, the one that we found, is called an extraneous solution. We found one, but it's not really an answer. It doesn't work. Yeah? Really, there's only one solution for this problem, even though you found 2 answers. Try one more? Okay, let's try one more. X minus 8 over x minus 5 equals x. We need to get the denominators to match. I'm just gonna, okay, so we know it's 1. We should multiply this fraction, top and bottom, by x minus 5. Yeah, whatever's there in the other denominator. In this case. Okay, so now the denominators match. X minus 8 over x minus 5 equals, I'm going to distribute the x. X squared minus 5x over x minus 5. Okay, we can eliminate the denominator. Multiply both sides by x minus 5. That'll cancel out the denominator. Yeah, balance, top and bottom, left and right. So, now we have x minus 8 equals x squared minus 5x. No fractions anymore. Since there's an x squared in the problem, we should try and get this in standard form. I'm going to get rid of the x and the minus 8. So now we have 0 equals x to the second minus 6x plus 8. There's an x squared in the problem. We should factor. We need x squared. So x and x. We need a positive 8 and a negative 6x in the middle. So gotta be minus minus 2 and 4. Okay, now we just solve each one for 0. X minus 2 equals 0. X minus 4 equals 0. And then we get x by itself. Okay, so we found 2 answers. Only question now is, are they both solutions? Yeah? Now, if you look back up here, negative 2 wasn't a solution because it produced a 0 denominator. So that's the easier way to do it then. We are going to take these, we don't have to plug it into the entire problem. We just need to make sure that our denominator here doesn't come out to 0. Yeah? So if I put a 2 there into the x minus 5, in place of x, 2 minus 5 is negative 3. So we know the 2 works. We're going to stick a 4 in now. 4 minus 5 is negative 1. No 0 denominator. So both of them are solutions. Yeah, if it had produced a 0 denominator, we can eliminate the answer as being a solution. Yeah? Not too bad? Okay. The homework is going to be just like this. All you got to do is achieve some balance. Either you multiply top and bottom by the same thing, so that the fractions will all have the same denominator. And then once you get the same denominator, then all you got to do is eliminate the denominator and then solve for x. If there's an x squared in the problem, we need to go to the factoring method. If not, then you just solve x like normal. Okay. We'll see you in the next one.